Welcome to Engage Math, Lesson 24, Problem 2. What we're doing is we're adding and subtracting expressions that contain a radical. A radical is sometimes the square root, as you know, and in all the problems that we have, A, B, C, and D, they're all square roots here. So just to make sure it makes sense, there's really a 2 that is the index, meaning we want the square root of each one of these, even though we don't write the 2. So the number inside that is called the radicand, and in order for us to combine by adding and subtracting these different expressions, the different terms within the expression, we have to make sure that the radicand is the same. So if we look at A, no problem, they both have the square root of 5. So all we have to do is combine the 8 and the negative 9, and we get negative 1, but I'm just going to write it in more simplified form as negative square root of 5. Okay, I'm going to zoom in now a little bit, for this one's going to take a little bit more work. Our first step is going to be 2 square root of x to the 8th. But remember, the x to the 8th can be simplified. So just to make sure, what we can do is, since the index is 2, even though it's not written, we could say 2 goes into 8 4 times. So our final answer here would be 2x to the 4th with none left over inside. And just to make sure that makes sense, remember the square root of x to the 8th is really the square root of x squared 4 times. And so we take out each one of those x squareds, and each one on the outside is just an x to the first. That's why this is our final answer. Okay, so that was just to help you think that through. Let's go to C. So you might look at C and be like, can't do anything because those radicands are not identical. But we can simplify. So the way that I'm going to show you to simplify, as you've seen in previous lessons on Engage Math, is that we could write the square root of 40 as 4 square root of 10. Square root of 4 times the square root of 10. And then we know the square root of 4 is 2. So this can really be 2 square root of 10. And then the 3 on the outside multiplies this 2. So what we get for that first term is 6 square root of 10. So once we have that, we can now move on to the 90. And I'm going to try and show you a couple steps at once, because we know that the square root of 90, just like the square root of 40, is going to have that factor of 10. And fortunately, that 9 is a perfect square. So 7 times 3 is 21. So we're going to say plus 21 root 10. And our final answer is going to be 27 square root 10. And we're done. Okay, let's go to D. So for D, we have 3 terms, and it doesn't look like any of them look too much the same. But again, we can simplify. This is a light bulb problem, so there's probably an extra little trick to it as we go through it. 3 square root 8. So I'm going to think of this as 4 times 2. And if you want, we can just think the square root of 4 is 2. So this becomes a 2 on the outside of the radical, multiplies the 3, so we get 6 square root 2. Then we have 50, which we know is the square root of 25, and the square root of 2. The square root of 25 is 5, so we're going to do 5 times the 2 that's out there, and we get a negative 10, and then there's still a square root of 2 left inside. Now, I think this is the reason it's a light bulb. This is a very common mistake where students will try to simplify the square root of 36 by breaking it down or finding a perfect square factor. But here's the thing. We know the square root of 36 already. We don't have to do any work. It's just 6, so we have negative or minus the quantity, 8 times 6, or just minus 48. And so our final answer will be negative 4 square root 2 minus 48. And we're done. All right, let's look at all of our answers together. And as you see, we have everything all written out. And I'll see you next time at Engage Math.